All right, ninth grade. Well, for this dissection, I wanted to take the time to discuss with you Loligo brevipenna. I wish we were in person doing this. But these guys are cephalopods. They're headfoots, and you're going to learn very quickly why I chose them. As a mollusk, they have a soft body covered with a mantle. Most mantles are covered with a hard calcium carbonate shell. These guys have a leftover shell called the pen that makes their body rigid and straight, like a little torpedo. But they have pretty much reduced that down to almost nothing. But they are cephalopods, or headfoots, which you're about to see. That their head is directly connected to the quote-unquote muscular foot. The muscular foot for these guys will be basically the tentacles, the arms where the suckers are. And so looking at this thing, it's almost like you want to stand them up on their muscular foot, the arms and tentacles, with the head resting on top of the foot and the mantle up above it. But these guys aren't oriented that way. I mean, their body is, but they, in their natural habitat, they're actually horizontal, not vertical, and they swim backwards away from the direction of their mouth. And so one of the reasons I picked these things is because of their odd orientation. It teaches us about ventral, which what you're looking at here with the belly side. Dorsal will be the back side. Their posterior is the pointy end in the direction they swim, and their anterior is their face end where the arms are. Most creatures move in the direction of the anterior, not the posterior. Here you can see the dorsal view where they have those chromatophores, those little dots all over their body. So they can change color, they can do patterns. They do that to disorient their prey and to communicate. But it's part of their defense because they don't have any armor or anything like that to speak of. So those chromatophores, along with their ink sac, is what they will use for protection, escape, and defense against predators. Their tentacles and arms have little suckers on them, which you're about to see. And by sucker, I don't mean they do the kind of thing where they, like you have on the windows or something like that. When you see the visual come up, these suckers have little bitty teeth on them. And so basically what they do is they will attach those to the surface of a fish, their prey, and they'll just give it a slight twist, and those teeth, those hooks, if you will latch on to the prey item until they can subdue it and bring it into their mouth, which you'll see in just a moment. And even in this slide, you can see the chromatophores up close on the edge of the tentacles. Once again, meant for camouflage, disorientation, defense, you name it. So the fact that they're cephalopods, that they're headfoots, these are the muscular feet, the tentacles, and the arms. But if we move on up, you'll see the head. And the head is directly connected to the muscular foot, because that is how they're going to catch their prey and eat. And so one of the cool things about all creatures, especially these, is that if they do things, if they hunt with their face forward, close to their mouth, if they have chromatophores to change coloration and patterns, then you can bet they have really good eyesight. So there's their eye, built differently than ours, but able to see pretty much the same spectrum. That glossy skin looking thing over the eye is actually like goggles when they're underwater that fills up and makes a nice round cap to it. And so in the wild, their eyes look much more clear because it's like they're wearing goggles underwater. And so their eyesight is very good. They're like the coyotes, the leopards, of the sea. They're very fast and nimble. And they are about, I don't know, 4 feet long. If we got to be in lab, you can see them. So you open them up on the underside, you can see their mouth. It's that buccal bulb, so you can see if they grab prey, they bring it in close to that buccal bulb. That's their mouth, which you'll see more up close in just a minute. And then that will dice things up, slice things up. Not really chew, it's more like a beak, which you'll see. And it goes directly into the esophagus. And so these guys latch on to, slice up, and swallow whole chunks of fish or whatever they're after. Now, one of the weird things about a soft-bodied creature, even though they're invertebrates, invertebrate doesn't mean you can't have hard tissues. They have that the calcium carbonate pen in their back. And they also have this beak, and it literally is like a parrot beak made of calcium. So it's not that you can't have hard tissue in your body as an invertebrate. As an invertebrate, it just means you don't have a central nerve cord surrounded by bone. But to have hard tissue is easily demonstrable. And so here, since there's nothing else to attach onto, it's like a ball of muscle that surrounds the beak. And when the muscle squeezes, the beak opens up, and when the muscle relaxes, the beak closes. So they eat a little bit differently than us, but it still works the same in terms of what its function is, but the mechanics are completely different in a soft-bodied creature. Now, speaking of the body, as we look inside, you're about to see first a male squid and then a female squid. Truly, on the outside and the inside, the male and female are completely identical except for the sex organs. Most of the females that we have in lab have a bunch of eggs that are unfertilized, and most of the males have that large yellow sac there where they keep their sex cells, their sperm. But other than that, they're the same. What we're really used them for is for their circulatory system. So on this slide and the next slide, if you can see gill heart, there's actually a gill heart on each side underneath each gill. And then they'll have a central heart, a systemic heart, or body heart. So they have 3 single chambered hearts. Each gill heart pumps blood to the gills to get oxygen, and then it comes back to the systemic heart, which sends blood to the rest of the body. So that last slide was pretty quick, but it's pretty much identical except for the female. But that's it. I wish we were together and dissect this thing live in lab, but take a look at this video and we'll have some questions for you at the end.